Hello guys, welcome back to another proposition video. Today we'll be another question here, and as always, let's first start off by reading the question. So, let n be a positive integer. And a good division of n in quotations is a partition of all the numbers 1, 2, all the way up to n into two disjoint non-empty subsets s1 and s2, such that the sum of the numbers in s1 equals the product of the numbers in s2. So, for example, let's say n is equal to 5. Then S1 is equal to 3 and 5, and S2 is going to be equal to 1, 2, and 4. And this would be a good division. So, for the first part A, find a good division for n equals 7. Now, we can see here, I write it up top here, in this little area, to save some space. We can see that all the factors, all the numbers below 7, below or equal to 7 would be 1, 2, 3, 4, 5, 6, and 7. Now, sadly, for this question, there isn't really a good way to solve this other than just using trial and error. And here we can see that the answer would be where S1 is going to be equal to 2, 4, 5, and 7. And S2 would be equal to 1, 3, and 6. Okay, so that's part A done. Let's look at part B. So find an n which emits two distinct good divisions. Okay, so for question B here, write B so you know this is for question B. Let's just consider S2 being equal to this subset of 1, x, and y. So let's just say that S2 is going to have three numbers here, 1, x, and y, for example. Okay? We can see for some number where 1 is going to be smaller than x, smaller than y, which is going to be smaller than or equal to n. Okay, and S1, right? S1 is the complement of S2 and 1 all the way to n. Now, this is going to be a good division if and only if n squared plus n divided by 2, I'll explain why later, minus 1 minus x minus y should be equal to the sum of numbers in S1. Okay, let me explain where we get this from. You can see here that n squared plus n divided by 2, this is just going to be the sum of all the numbers from 1 to n. And what is the minus 1 minus x minus y here, you may be asking? Well, this is all of the terms in S2 that I just said. For example, let's have S2 have these three terms in it. Well, we can see here that the remaining terms, right? So this is every single term, and we know that 1, x, and y is in here. So by removing these, we're just left with the sum of the numbers in S1. And the sum of the numbers in S1 is equal to the product of all the numbers, So we know that the sum of the numbers in S1 is the product of the numbers of S2. That's kind of the whole point of the question, right? And we know the product of the numbers of S2 is just going to be equal to xy. So in other words, n squared plus n divided by 2 minus 1 minus x minus y is equal to the sum of the numbers in S1, which is equal to the product of the numbers in S2, which is equal to xy. So in here, we can just now look at these two and look at these two relations here. So we get n squared plus n divided by 2 minus 1 minus x minus y, and this is going to be equal to xy, right? And this we can rearrange it into x plus 1 times y plus 1 is going to be equal to n times n plus 1 divided by 2. So why did I do this? Well, we can see here that we can just plug in a bunch of numbers and see whether or not they work for n. So we can see here that if n is equal to 10 here, right? So if n is equal to 10, let's just say, I'm going to move over here. So let's say n is equal to 10. What would happen if n is equal to 10? Well, we can see here it's going to be pretty simple. This would be equal to, as you can see here, we would have x plus 1 times y plus 1. This would be equal to 55 because, well, 10 times 11 divided by 2 is 55, right? And this could be equal to 5 times 11, right? And this also means that we can have x and y be equal to, so this means that x would be equal to 4, and y would be equal to, let's just say, 10. So this means that the two solutions for this would be, so now the one solution for this would be if S1 is equal to all the numbers, so I'll just write, actually no, we don't need to care about S1, we say S2 is equal to 1, 4, and 10. And then S1 would be equal to, oh, I don't know why I write those regular brackets. And then after that, we have S1 equal to all the numbers from 1 to 10 that are not in S2, which would be 2, 3, 5, 6, 7, 8, 9. But obviously, this is only one pair of S1 and S2. So what about the other pair? Well, for the other pair, we can do the same exact thing as we did above here, except what if, as I said before, what if S2 doesn't have 3 terms? What if it only has 2 terms? What if it only has X and Y? Well, this would actually be the same exact thing. I actually need another paper for this. Let's switch over to this one paper that I have here. So we're going to do the same exact thing as we did before, but instead of S2 being instead of assuming that S2 has 3 terms in it, let's assume that S2 only has 2 terms in it. So let's assume that S2 is going to be equal to, so going along with before, let's just say S2 is going to be equal to 6 and 7. Right? Let's just say, not 6 and 7. I don't know what I'm doing. X and Y. Right? So let's just say S2 is going to be equal to X and Y. So instead of 1 X and Y, let's just do X and Y. So as before, it would be the same thing. N squared plus N divided by 2 minus X minus Y. This would be equal to, obviously, the sum of the numbers in S1. So I'll write sum of S1. And this will also be equal to the product of S2, which is going to be equal to XY. So similar to before, we have the sum of all the terms in, below N or equal to N. Then we minus the terms from S2, and what should be left is the sum of the numbers of S1, which, given by the question, is going to be equal to the product of S2, which the product of S2 is equal to XY. And then after that, we did the same thing, where we move the XY, we look at N squared plus N divided by 2 minus X minus Y, and XY, and we factor it to receive X plus 1 times Y plus 1 is going to be equal to N times N plus 1 divided by 2 plus 1. Right? Now, similar to before, let's plug in N is equal to 10 again, right? This would be turned into X plus 1 times Y plus 1, which is going to be equal to 56, right? And so this means that X would be equal to 7 in this case, and then we can say Y is equal to, so no, X is going to be equal to 6, and Y is going to be equal to 7. So in other words, what we did here is that we took S2, and we said, okay, what if S2 has 3 terms? What if it has the 3 terms 1, X, and Y? And then the second time we did it the same thing, except we say S2 only has 2 terms, X and Y. And then using these, we can both plug in N, right? We both plug in N, and as you can see here, for N is equal to 10. So in total, for N is equal to 10, we have 2 possible pairs of S1 and S2. So our first pair, as I just solved on the other page, would be if S1 is going to be equal to 2, 3, 5, 6, 7, 8, and 9. And then if S2 would be equal to 1, 4, and 10. And then the second pair that I solved over here, with S2 only having 2 terms in it, would be where S1 is going to be equal to 1, 2, 3, 4, 5. And then after that we jump 6 and 7 to 8, 9, and 10. And then S2 would be equal to 6 and 7. So we can see here that if N is equal to 10 here, as I just said, for example, we can see that there's two pairs of S1 and S2. So yeah, that means we found an N for which N admits 2 good divisions. So N is equal to 10 here. I'll write that down. Now let's look at C, which will show that if N is going to be bigger than or equal to 5, then a good division exists. So I'm just going to remove the other equation. Let's just look at this one right here on this page. N squared plus N divided by 2 minus 1 minus X minus Y, sorry. Right, now that we factor it into here, actually, we need to look at this part. So this part in particular, X plus 1, Y plus 1 is going to be equal to N times N plus 1 divided by 2. Now we can see here pretty simply that let's split this into 2 cases, okay? So what if n bigger than or equal to 5 is even. Right? Why does this matter? Well, because if n is bigger than or equal to if n is even, we know that there's a different amount of terms based on whether or not n is odd and how you can split them up. So here, let's say n bigger than or equal to 5 is even, right? Then this means that here we would need both x and y to be even. And so we can let x be equal to n minus 2 divided by 2, and we just let y be equal to n. This way, both of these numbers are both going to be actual integers, right? Because as you can see here, n minus 2, right? And in this case, let's say n is even. On top, we have an even number minus an even number, which is still an even number, divided by 2. This would be an integer. And then obviously y is equal to n. We know n is an integer. So our second case is, what if n bigger than or equal to 5 is going to be odd? That's an n, not a w, sorry. N bigger than or equal to 5 is going to be an odd number. What would happen here? Well, similar to before, you can see here that we need, let's just say x is going to be divisible by 2, because we look at this number here, we can split this into n minus 1, so not n minus 1, n plus 1 times n divided by 2, right? Or we also split it into n plus 1 divided by 2 times n. Right, so we can split this up, and since in the second case, what if n is going to be odd here, you can see here we need to change it around to make sure that both x and y are both going to still be integers. So x here would be equal to n minus 1 divided by 2, and y here would be equal to n minus 1, and if you plug in both of these, you'll see that they both be equal to n times n plus 1 divided by 2. So that's the answer for C. This is the proof. Thank you guys for listening. If you've any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.